এখন দেখা যাচ্ছে?
This call is now being recorded.
হ্যাঁ স্যার, দেখা যাচ্ছে।
Our today's topic is switching. Switch network example is like how node A transfer data to node F. So all the nodes or computer need to be connected in some form physically. Okay, it is called like switching between A, B, J and other C. It is connected via switch I. Okay, so similarly the next connection is through switch 2, then 3, then 4. Okay, there can be a second path like 1, 5, 4. Okay, so selections of path is based on some kind of cost, length of cost or speed of the network, that will be covered later. But this switching network or switch network are categorized into 3 different types. First is circuit switch network, second is packet switch network, and third is message network. Okay, this packet switch network is again categorized into datagram network or virtual circuit network. What is datagram network? It is connectionless packet switching. And what is virtual circuit network? It is connection oriented packet switching. Okay, so both are different. Okay, so mostly we will cover circuit switch network and then datagram network, and then we will cover virtual circuit network. Okay, 3 different types. Start with the first type, circuit switch network. Consists of a set of switches connected by physical links. A connection between two stations is a dedicated path made of one or more links. However, each connection uses only one dedicated channel on each link. Each link is normally divided into n channels by using FDM or TDM, means frequency division multiple access or time division multiple access. Okay. See, so this is an example of circuit switch network where if you have to transfer data from A to M, it has to travel from switch 1 to switch 4 to switch 3. Okay, for that internal circuits will be followed via the colored red color line you can see in my animation. Any path selected between this and then traveling will be via this. Okay. So there will be a kind of circuit. Okay. Circuit through the switch 1 to switch 4 to switch 3. That's why it is known as circuit switch network. Okay. Let's see again. This circuit switch network made of a set of switches, okay, connected by physical links, in which each link is divided into n channels. Okay, so each link is divided into n channels. Like how many channels you are using? It can be 5, 6, 7, any channels. In circuit switching, resource need to be reserved. Okay, please remember this line. Resource need to be reserved during the setup phase. The resources remain dedicated for the entire duration of data transfer until the tear down phase. Let's take old telephone concept. Like if you're dialing from your line phone 1 to line phone 8, okay, before you can communicate between 1 to 8 via voice call, a circuit need to be completed, okay, via, say, this circuit will be followed via switch 1 to, say, via switch, oh sorry, this one S2 8, okay. So this physical connection between these devices are established first, and then communication take place. So that's why the meaning is that resources are reserved first, and that resource remain for entire duration of data transfer, okay, until you close the phone. So in earlier days also you can see, like, before dialing to a number, you can call to the exchange, please connect me to number XYZ, okay. During that period, an exchange operator used to connect your phone with the destination phone number, then only you can talk, okay. That is an example of circuit switch network, okay. See this example. Here it is showing a 4x8 switch, okay, another 4x8 switch. Using 4x8 switch, you can communicate between 4 different computers, okay, to other 4 different computers simultaneously, okay. So what it does, at the sender side, let's take it is at location 1 and it is location 2, and the distance is, say, let's take 1000 kilometer, okay. For 1000 kilometer, to communicate from 1 to 4, or to communicate between 4 to 1 or 2 to 3, or say 4 is communicating to other 4 simultaneously, at least how many wires you require? If you communicate, you require, say, 1 to 1, 1 to 2, 1 to 3, 1 to 4. If you require dedicated line, at least from 1 sender to 4 receiver, you need 4 lines. Similarly, from 2 to other 4, you require 4 lines. 3 to other 4, you require 4 lines. 4 to 4, you require 4 lines. Basically, 4 cross 4, 48 lines you require. So for 48 lines, you require length of your wire should be 1000 kilometer into 48. Means the cost is you have to bear is for 48,000 say kilometer wire you have to spend. So that is impractical. It is not possible to bear so much cost. Say you take it as something capable of, say, 10 rupees also, then also you require 4,80,000 wires only. So to reduce the cost of wire for long distance communication or for other different reasons, what they do, they used to do some kind of multiplexing where they combine all the data from location 1 to location 2 via a single dedicated line, okay. So they are using one single line to communicate between location 1 to location 2, okay. They used to merge all the data from 4 senders to transmit from this position to other position via some kind of multiplexing. So at that point, you need to use switch, okay, so that it can select path 1 from 1 to the rest, or 2 to the rest, or 3 to the rest, or 4 to the rest, okay. So this is the role of switch or circuit switch network. How switch can be used, this is an example, okay. In circuit switch network, if you are transmitting data from A to B, there can be some kind of delay for connect operation. Like from point 1, you are transmitting a hello message that I am willing to send data to you. So B will receive, okay, A want to send data to me. B will reply, okay, you are eligible to send your data. Okay, so for that duration, it is for connection it is the delay. Okay, then this is the time taken for data transfer. Okay, this total time taken is for this data transfer. So if it takes 10 minutes, then here also it will be like 10 minutes. Okay, then after completion of data transfer, at this point B replies with a acknowledgement to A. What is the time duration? This is the time duration required for your disconnect operation. Okay, this duration is for disconnect operation. So if you can sum the connect time duration, data transfer duration, disconnect time, you will be able to get total delay from
Sir.
point A to B.
স্যার আবার দেখা যাচ্ছে না প্রেজেন্টেশনটা।
অটো ক্লোজ হয়ে যাচ্ছে। Some problem is there. Visible?
Yes sir.
Okay, let me know always, because I cannot see now presentation is visible or not.
Okay.
So have you understood this delay part? This slide was visible to you earlier? Have you understood this circuit? And then I have explained delay part. Have you understood? Okay. So switching at the physical layer in the traditional telephone network uses circuit switching approach, as I just told to you. So what we have completed, we have already covered the circuit switch network. Okay, let's start with the second type. Second type is your datagram network. In the second type, datagram network says that in data communication, we need to send messages from one end system to another. If the message is going to pass through a packet switch network, it needs to be divided into packets or fixed or variable size. The size of the packet is determined by the network and the governing protocol. So what is said here, let's try to understand. So the topic datagram network says that if you want to send data from A to X, your data need to be divided. Like here they have divided in the form of packet 1, packet 2, packet 3, packet 4. So at the receiver side, it may receive the data 1 first, then it has received 4, then it has received 3, then 2. Maybe for delay, it is receiving packet in different order. So X has capacity to organize the packet in proper form. After receiving, it will convert it into 1, 2, 3, and 4. then it will join the packet in the form of complete data, and then it will deliver it to X. So now question is, using datagram network, how is able to transmit data to X? Please remember that in all cases they are using some kind of switch. Okay, like here 5 different switches are used to connect other computers, like A, like let's take it's B, and that is as Y, and that is a X. Okay, now A may send data to the switch, let's take it as 1. So let's take it as a 2 number switch, that is 3, and that is 4. That received data 1, 2, 3, 4 may be traveled to the other destinations via say path 1, path 2, or path 3. So in the figure you can see 3 is traveling in different direction, 4 in different direction, 2 in different direction. Okay, so there may be chances that different paths are followed, but then also somehow it will reach to the 4th number switch following different path, maybe through path 1, through path 2, or through path 3. Okay, so because it is using different directions, different path, then there can be possibility that the delay is measured in terms of delay between A and first switch to second switch to the destination. Okay, so transmission time, then after that transmission between A to switch 1, it is transmission time. Then waiting time between your second transmission between switch 1 to switch 2. Then waiting time between your switch 2 to B, and the actual data transmission time. So basically you will see you are starting from point A and you are able to complete your data transmission at this point. So this complete duration is your total delay for datagram network. Okay, so let's take it as a time t1 for data transmission plus waiting time t1 plus time taken for data transmission 2 plus waiting time 2, then transmission time 3. Okay, that total will be the delay for datagram network. I hope it is clear. Okay, so datagram network uses some kind of destination address and output port, that is a table. That is a table maintained in the switch, like for which data destination address which port will be used. Like for 1232 kind of destination address, port number 1 will be used. Like for 4150, port number 2 is used. For 9130, port number 3 is used. So each point it decide based upon the table data. Okay, switch decide the path based upon the data stored in the table known as routing table. So routing table means it stores some kind of information that stores the path, routing information. Okay, routing table stores routing information. So this is an example. So a switch in a datagram network uses a routing table that is based on the destination address. Okay, Destination address in the header of a packet in a datagram network remains the same during the entire journey of the packet. Okay, I hope you can relate. For transmission from A to X, destination is X, not switch 1 address or switch 3 address or switch 4 address. Okay, so the destination address never changes, it remains the same during the journey of the packet. Okay, switching in the internet is done by using datagram approach to packet switching at the network layer. Okay, now if you have understood the type 1 and type 2 switching, now we will start with third type known as virtual circuit network. A virtual circuit network is a cross between a circuit switch network and the datagram network. Okay, it has some characteristics of the both. Means if you have understood circuit switch network and datagram network, then it will combine the advantages of datagram and circuit together to form your virtual circuit network. Okay, this is an example of virtual circuit network where you can see that n systems are connected via some kind of switch. Virtual circuit network uses a virtual circuit identifier. Okay, means with data there will be some type of VCI, virtual circuit identifier. Okay, then how it works, like a switch will store routing table. Okay, this routing table will have some information for incoming and some information for outgoing. If for incoming it is written input is possible through port 1, VCI will be 14 or 77. Okay, means data with VCI 77 and 14 are allowed to be delivered to switch or allowed to be as an input through your port 1. Okay, like for port 3 only 22 number identifiers are allowed. For port 2 only 41 number identifiers are allowed. Okay, for incoming this path, for outgoing this path. Okay, 2 path. So they have written port 3 2 as outgoing. Okay, so data transfer is possible from 1 to 2 or from 1 to 3. Okay, check one more example. Like if you want to transfer data from A to B, how you can transfer using virtual circuit network? Say data with identifier 14 is allowed through port number 1. Okay, so you will see this table incoming. So that is input is allowed, done. Then output is only possible through 3. Okay, and the identifier used will be CTC. So 4 and 2 are not selected, 3 is selected. Okay, port number 3 is selected. So with data it will append the VCI as 66, not 14. 14 is discarded and 66 is appended. Okay, now for this switch, the table shows that for port 1 it will accept 66 number VCI, and for output it will use 22. So this data will be delivered and it will be sent again, but with data new VCI is used, it is 22. Okay. Now for this switch you check the incoming and outgoing. Here they are using 2-number port for VCI data 22. So 22 will be delivered, data will be delivered to the switch. And for output it is using port number 3 and VCI will be used is 77. So through the port 3 it is transmitting data and it is using VCI 77. Okay. So using VCI, if you transmit data, you have to use your VCI as input is 14 and output VCI is 77. Okay. That is source to destination data transfer in a virtual circuit network. Okay. That is possible with the help of some kind of a virtual circuit identifier. Okay. That is another example of the same figure, how setup request is established. Okay, first communication A take place, then B, then C, then D, just as I have explained. Okay. Then how reply is sent. Okay. In the setup phase, you may not know the output your VCI. Okay. So during setup, you are establishing a path using A, B, C, D. Then after that, D will reply to the same path. Okay. During reply, you can note down the VCI identifier. Like it is informing that okay, my VCI is 77. Then it is informing that my VCI is 22. Okay. Since it is informed 77, update 77. Since it is informing 22, update 22. Then through this channel, you are updating 66, so update 66. And then from that, you already know your VCI 14, so that will be 14 will be delivered to A. Okay. So that is setup phase, then acknowledgement phase. Okay. First setup, then acknowledgement. Okay. That is setup request and that is setup acknowledgement. Okay. So it is two-way communication. So in virtual circuit switching, all packets belonging to the same source and destination travel the same path. Okay. Please note down this definition. From this you can clearly see circuit connection means all data will travel through one path. Datagram switching means data travel from source to destination using different paths. Virtual circuit switching means it makes group of packet. A group of packet is delivered using a same path. Means all the packet belonging to same source. Okay, belonging to same source and destinations travel the same path. Okay, एक ही source से destination होने से use same path. But packet may arrive at the destination with different delays. Okay, if resources allocated is on demand. Okay, डिले होगा अगर हर एक टाइम पे आप एलोकेशन करते हो, माने रन टाइम. इफ रिसोर्स इज एलोकेटेड डायनामिकली ऑन डिमांड करते हो तो फिर डिले होगा. ओके, सो सी दे आर सेइंग दैट okay, let's try to compare. Earlier one, just give me 1 minute. See clearly. Type 1, establishment, data transfer, ACK. Okay, so delay was total delay. Then type 2, delay was in each phase, waiting time. Okay. So the delay in datagram network was in each phase. Now here they are showing only 2 switch. If there can be 5, then 5 time waiting time will be there, and 5 time transmission time will be there. Okay. But now for establishment, they are using same time. That is for setup. For data transmission, that is T1 plus T2 plus T3. But at least waiting time is not there. And then that is your acknowledgement or tear down time. Okay. So here delay will be sum of setup time plus transmission time 3 times plus your tear down time. Okay. There is a delay in virtual circuit network. Okay. Switching at the WLAN layer in a switched wireless WAN, that is wide area network, is normally implemented by using virtual circuit technique. Okay. So where virtual circuit network is used, it is used in wide area network. Please remember that. Okay. So switching at the WLAN layer in a switched WAN is normally implemented by using virtual circuit technique. So what I have covered? Type 1, type 2, type 3. 3 type of switching. Any question? Other students? Okay. So since you have understood the 3 type of switching, now try to understand the structure of a switch. Okay. Basically, let's take 3 lines, 1, 2, 3, and 4. Let's take this is as input. Okay. There are 3 lines for input. Then these are for output. Okay. Basically, this 3 input line will be connected to other 4 output line. Okay. Let's try to understand that. It's like your keyboard. Whenever in keyboard you press A or B or C, how does it work? Means it has some lines in rows and some other line in column. Some line in rows are say in layer 1, okay, and the other columns are in layer 2. Okay. Whenever you press a button, means you are trying to connect the column with the row. Like whenever you will press this point A, means this, try to understand, 3 lines in rows and 4 lines in column. That is in layer 1. सोचो कि ये पेपर 1 पे है and this is in paper 2. Then place one paper on top of the other paper. Means what? They are in different layers. Basically, you are connecting row with column. Okay. So whenever you will press A, this column will be connected with this row in this position. So at this position, it will be marked as A. At this position, it is pressed, it is marked as B. It is marked as C. It is marked as D. In this way, the short circuit formation take place, circuit completion take place, and this information is sent to the CPU from the keyboard that okay, some buttons are pressed and their position is this, and those position mean that these are the keyword, or these are the letters. Okay, it is key A or B or C or something like 1, 2, 3, 4. Those points are known as your cross point. Okay? Those points are known as your cross point. So if this figure is clear to you, let's try to show you a bigger figure. Means if you have, let's take 100 users as capital N and 100 users at receiver side. Okay, so you are trying to use 100 different lines as input and 100 different lines at output. Then how multi-stage switching can be used to connect those different users from location 1 to location 2. In this case, at different stages, different switches will be used. Like what they will do, they will group this 100 users into different subgroups. Like let's take small n as 10. Means 10 group of lines are transmitted through switch 1. 10 other groups through switch 2. 10 other groups through switch 3, and similarly it will continue. Okay, so let's say 100 is for capital N, 10 is for small n. In such cases, how many switches you need to use? At stage 1, it is 100 divided by 10 group, basically it is 10 again. Means you need 10 switches at stage 1. Okay, if you can group them into 20 groups, so how many switches you require? It will be like 5. Means 5 switches at stage 1 will be sufficient. Okay, that switch has input as N, so there will be output also, like 10 cross 2 which can be there. Means it will accept 10 input line and output only with 2. So they are using, in this figure, using line 1 and line 2. Okay, since output is 2, so at stage 2 it will be again, output will be how much? Like 2 switch will be used, because one input will go to crossbar switch 1 and another will go to crossbar switch 2. Okay, see again, I am trying to convey you that in multi-stage switch, to connect n users with other n users, you have to use different switches at different stages. In this figure, they are using n by n crossbar switches at stage 1, k crossbar switch at stage 2, and n by n crossbar switches at stage 3. Capital N example 100 and small n example 20. Okay, so here also 100 divided by 20. How much? Means say example it will use 5 switch. It will use 5 switch. Okay, so 5 input cross how much output. If you are selecting 2, then k is you are selecting as 2, means intermediate switch will be 2 number. Okay, so it can be 5 cross 2. That's why it will be like opposite side it will be 2 cross 5. Okay, and here it will be like your input will be n divided by n, means 5 cross 5. Okay, how we are trying to identify? Because it is n by n cross n by n. Okay, so capital N is your 100, small n is your 20. So you are using 5 cross 5 switch of how many? 2. You are using 2 cross 5 switch of how many? Okay, n by n means 5. Here you are using 5 cross 2, how many? 5. Basically you are using 5 plus 2 plus 5, that is 12. 12 switches are sufficient to connect your 100 users with the other 100 users. Now it is clear to you that how switching can help you to reduce the cost of wire or number of lines required for communication between two locations. So there is a formula in a 3-stage switch. Total number of cross point will be 2kn plus k into n divided by n square. Means they are trying to find how many cross points are there in this figure. How many cross points are there is able to be calculated with the help of 2k n plus k capital N divided by n. If you know your small k as 2, capital N as 100 and small n as 20, then how many cross point will be there? It will be like 2 into 100, that will be some plus 2 into 100 divided by 20 square. Is it clear to you? So how many? So you can find here it is 2 cross 2 is 4, here it is 400. Okay, 400 plus it will be like 5. 5 into 5 it is 25. 25 into 2 it is how much? 50. So here the result will be 450. Okay, I have shown one example where k is given, capital N is given, small n is given. Then how many cross point? It is 450. Okay. अगर आप मल्टी स्टेज स्विचिंग यूज नहीं करते तो ये 100 यूजर, अगर 100 यूजर से बात करना चाहते हो, ठीक है, तो आपको कितना लाइन चाहिए होगा? 100 स्क्वायर. ये जनरली होता है n स्क्वायर. मीन्स हर एक लाइन से कम्युनिकेट है. तो इसका आंसर हो जाता है आपका 100 स्क्वायर मीन्स 10,000 लाइन. तो आपका 10,000 क्रॉस पॉइंट नहीं होके अगर सिंगल स्टेज में आप यूज करते तो 10,000 होता, लेकिन मल्टी स्टेज किया तो ये 450 हो गया. ओके, लेट मी रिवाइज इट अगेन. In multi-stage switching, advantage is that it reduces number of cross point. अगर सिंगल स्टेज स्विचिंग आप करते तो आपका फॉर्मूला होता n स्क्वायर. अगर आप 3 स्टेज स्विचिंग करते हो तो आपका फॉर्मूला हो गया ये 2kn plus k n divided by n whole square. For what? For finding नंबर ऑफ क्रॉस पॉइंट. ये एक न्यूमेरिकल आएगा. So similarly, questions in examinations can be like design a 3-stage switch with 200 cross 200 switch where capital N is 200 with K equal to 4 and N equal to 20. Okay. So try to do those kind of numerical. So rest of the slides are not required. So this will be the end of class. If any questions, please let me know.